The James Webb Space Telescope has emerged as a game-changer in our quest to understand the universe, and it's doing far more than just capturing stunning images of distant galaxies. In fact, it's forcing scientists and theorists to rethink some of the most fundamental concepts of reality itself. One of the most astonishing revelations to come from Webb's observations is the unsettling possibility that everything we know about time might be fundamentally wrong. Suddenly, we're faced with the possibility that we may have to rewrite entire chapters in our textbooks about the beginning of the universe, and the nature of existence. The more we observe, the more we begin to wonder, is time even real? For most of us, time feels like the ultimate constant in our lives. We're governed by the ticking of the clock, by the cycle of days and nights, by the gradual accumulation of years. Time seems like a solid, undeniable framework for our lives, a rhythm that can't be disrupted. It's as though time is the very fabric that holds everything together, the one force that is unchanging, no matter what. But what if this perception is wrong? What if time is not the constant we've always believed it to be, but rather an illusion, a mere byproduct of our limited human perspective? This is the bold assertion made by one of the brightest theoretical physicists of our time, Michio Kaku. Kaku's claim that time does not exist isn't just a philosophical musing. It's a radical idea that is rooted in the most cutting-edge discoveries in modern science, particularly those unveiled by the James Webb Space Telescope. Webb, the most advanced telescope humanity has ever built, is not just peering into the cosmos. It's revealing mysteries so deep and complex that they force us to rethink the very nature of reality itself. To understand Kaku's bold assertion, we first need to ask ourselves, what is time? What is it, really? For centuries, humans treated time as an absolute, universal backdrop against which everything else unfolded. In the classic view, popularized by Sir Isaac Newton, time was seen as a steady ticking of a universal clock, a force that moved forward relentlessly, independent of the events unfolding around it. But this perspective began to unravel with Albert Einstein's theory of relativity, which revealed that time is not a fixed, unchanging backdrop. Instead, time is a flexible dimension, one that is intricately woven into the very fabric of space. Einstein's theory showed us that time could warp, stretch, and slow down depending on factors like gravity and velocity. Time, in this view, wasn't a rigid, universal framework, but something that could bend and shift. This radical rethinking of time set the stage for even stranger and more mind-bending revelations, many of which are now being explored through the discoveries made by the James Webb Space Telescope. So, what exactly has Webb uncovered that is so radically different from what we've always assumed? To understand this, we need to take a deeper look at how Webb works. Unlike the Hubble Space Telescope, which captures visible and ultraviolet light, Webb is designed to detect infrared light, essentially the heat emitted by objects in the universe. Infrared light is crucial for studying objects that are incredibly far away, as the farther an object is, the longer it takes for its light to reach us. In a way, when Webb observes distant galaxies, it's like looking back in time. The light Webb detects isn't showing us the present state of these galaxies, it's showing us how they looked billions of years ago. This is not just a scientific curiosity, it's a window into the past of our universe. For example, when Webb captured its first deep field image, it revealed galaxies that formed just a few 100 million years after the Big Bang. These ancient galaxies are fascinating because they are far more evolved than scientists expected them to be at such an early stage in the universe's history. Some of these galaxies appear larger, brighter, and more massive than they should be given their age. This has led scientists to wonder, could these galaxies have evolved faster than the laws of physics should allow? Could time, as we understand it, be different for these distant galaxies than it is for us? In essence, could time itself be something more subjective, something that depends on how and where you're observing it. Kaku suggests that these strange observations might provide evidence for a radical idea: time may not be a fundamental property of the universe, but rather an emergent one. In simple terms, time may not exist independently of the other processes happening in the universe. Instead, it could be a byproduct of deeper, underlying mechanisms at play in the cosmos. To grasp this idea, imagine a river. To us, the river appears to flow in one direction, from upstream to downstream. But that flow isn't an inherent property of the river itself. It's the result of gravity, the landscape, and countless other factors that influence how the water moves. Similarly, Kaku suggests, the flow of time we experience might not be an inherent property of the universe but a consequence of the way we interact with it. This raises some profound and challenging implications. If time is an illusion, then what does that mean for the world of quantum mechanics? In the strange, counterintuitive world of quantum physics, time behaves in ways that defy our normal understanding. At the quantum level, particles can exist in multiple states at once, and they don't follow the laws of classical physics. In this quantum realm, the distinctions between past, present, and future blur together, making the concept of time almost meaningless. The James Webb Space Telescope is providing scientists with unprecedented data that could help us understand these quantum phenomena on a cosmic scale. By studying the light from ancient galaxies, Webb is not just showing us what the universe looked like billions of years ago, it's giving us clues about the very nature of reality itself. The more scientists analyze this data, the more they begin to see patterns that suggest time, as we understand it, might be an illusion. But if time doesn't exist, what does that mean for us? For our everyday experiences, for our understanding of life, death, and existence. This is where the philosophical implications come into play. If time is an illusion, then so are concepts like before and after. What if the past, present, and future are not separate entities at all, but part of a single, unchanging reality? This idea is supported by something called the block universe theory, which proposes that the universe is like a giant block of space-time, where all moments, past, present, and future, exist simultaneously. From our perspective, we experience time as a series of moments, unfolding one after the other. But in the block universe, all those moments exist all at once. They're all there, timeless and unchanging, as if the entire film of our universe exists in its entirety right now. If this is true, the implications are staggering. The idea of free will, of making choices and shaping our own destiny, becomes much harder to grasp. If all moments in time are already fixed, then are our actions truly our own? Or are they predetermined? Some people might find this idea terrifying, believing that it strips away the spontaneity and agency from life. But others, like Kaku, see this as an opportunity to reconsider our place in the cosmos. If time is an illusion, then perhaps death is too. If all moments exist simultaneously, then birth and death are not endpoints but equally present in the fabric of the universe. In this view, life is not a brief, linear journey from beginning to end, but an eternal feature of the cosmos, one that exists outside of time. The James Webb Space Telescope has given humanity a glimpse into this timeless reality. By peering deeper into space than ever before, it's showing us a universe far stranger and more complex than we ever imagined. It forces us to question everything we thought we knew, not just about the universe, but about the very nature of existence itself. And this is just the beginning. As Webb continues to explore the cosmos, it will undoubtedly reveal even more astonishing and confounding truths that challenge our most fundamental assumptions. Time, space, and even reality itself may